In this video, we will discuss the rectangular coordinate system and some of the basic associated properties. So first of all, we have the rectangular coordinate system sketched here. The idea is that this horizontal axis, we refer to that as being the x-axis. The vertical axis is referred to as being the y-axis. Now, these two coordinate axes, the x and the y, they break the xy coordinate plane up into four quadrants. We think we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Additionally, every point inside this rectangular coordinate system can be labeled as an ordered pair. So if I just go ahead and randomly pick a point here, we can label it as A comma B, where A and B are numbers. And what these quantities are representing is if you trace down to and over to the respective axes, the A is how far you are in the x direction, and what this is going to measure is, say, the directed distance from the y-axis. And when you trace over to the y-axis, you're at B, and what that is going to measure is how far you are above or below, i.e. the directed distance from the x-axis. Now a few basic properties of the coordinate system. Something that we've most likely encountered in the past is the Pythagorean theorem. What the Pythagorean theorem tells us is that if we have a right triangle and its legs have lengths A and B, and the hypotenuse has lengths C, then a squared plus b squared equals c squared. And the Pythagorean theorem is used directly to come up with the distance formula. If you have 2 points in the coordinate system, x1, y1, and x2, y2, we will say the distance between p and q, oftentimes expressed as absolute value of pq, is the square root of the difference of their x values squared plus the difference of their y values squared. And let's see how this comes from the Pythagorean theorem in this next example. I would like to find the distance between the points minus 2, 6 and 5, 5. So let's say minus 2, 6 is about here, and 5, 5 is about here. And what I'm going to go ahead and do is draw a right triangle associated with this. I'm going to go down 1 and then over to that point. And if we think about the length of each side of this right triangle, this vertical leg that we have on the left is going to be the difference in the y values of our 2 points. So we're at 6 for a y value, we go down to 5. So 1. The bottom leg is going to be the difference in the x values. You're going from minus 2 to 5. So 7. So by the Pythagorean theorem, the length of that hypotenuse, the c value, is going to be the square root of 1 squared plus 7 squared. So that would be the square root of 50. And that hypotenuse is the distance between the 2 points. So let's apply the formula directly. So the distance is going to be the square root, and we take the difference in their x values. So x2, y2 would be the second point, x1, y1, the first point. So we have x2 minus x1 squared. So we have 5 minus a minus 2 squared plus 5 minus 6 quantity squared. So this becomes the square root of 7 squared plus minus 1 squared. 7 squared is 49, 1 squared is 1. So once again, we find that that distance is the square root of 50. So let's look at a similar type of example where we're going to put the Pythagorean theorem and put this distance formula to work for us. that sketch the triangle with these prescribed vertices and use the Pythagorean theorem to determine if it's a right triangle. So we have -2, 6, 5, 5, and note those should be familiar points. We just worked with them in our previous example. And 1, 2. So carefully draw the right triangle, or excuse me, the triangle with those vertices. And the question becomes, is this a right triangle? I'm going to go ahead and label these points. -2, 6, 5, 5, and 1, 2. So this is point B, point A, and point C. So in order to see if this is a right triangle, what we have to do is verify or check if the length of each of these sides is going to match up with the Pythagorean theorem. So we need the length of this leftmost side, so that'd be the length AB, of the rightmost side, BC, and the upper side, AC. So from our work on the previous slide, we have seen that AC is equal to the square root of 50. We now need to calculate the length of, say, the side AB, and in a moment the side BC. So the side AB, we take the square root, we take the difference of their x-coordinates, so 1 minus -2 squared, plus the difference of their y-coordinates squared, 2 minus 6 squared. So that would be the square root of 3 squared plus 4 squared, which is the square root of 25, which equals 5. Similarly, if we want the length of BC, we take the square root, and then we take the difference of their x values squared, plus the difference of their y values squared. So the square root of 4 squared plus 3 squared, square root 25, 5. And in order to see if the Pythagorean theorem is satisfied, we need to know that if we take two of the sides and square them and add them up, we will get the square of the third side. So in our example, when we combine this all together, so this is our verification, if we take AB quantity squared plus the length BC squared, we're going to have 5 squared plus 5 squared is 50, because 5 squared is 25, and that equals the length of the side AVC squared. So combining this together, the answer is yes, triangle ABC is a right triangle. So an interesting application of this distance formula combined with the Pythagorean theorem. Now, kind of a last formula that we should be familiar with is the midpoint formula. If you have a line segment joining 2 points, it's often useful to know what is the midpoint of that line segment. And you find that midpoint by taking the average of the x values and the average of the y values of the corresponding points. So this formula, this should really be plus x2 squared, and this should be y1 plus y2 squared. So the average of the x values, the average of the y values. So for these points we've been working with in the last few examples, -2, 6, and 5, 5, the midpoint of these 2 points, let's go ahead and call it M, is going to be the average of their x-coordinates, so -2 plus 5 over 2, and the average of their y-coordinates, 6 plus 5 over 2. So that would be the point 3/2, comma 11/2. So once again, to reiterate, that first point is the average of their x-coordinates. The second part here, the average of their y coordinates.